Hi everyone. So we're going to talk about water cycles today. And one of the problems when it comes to trying to figure out fresh water, and mainly the biggest thing with fresh water is that's what humanity uses. That's what people use. That's the requirement for life for us. So we're going to talk about the fact that there's only about 3% of the water in the world that is fresh water. It seems like it's such a small amount, but the reality of it is that is more than enough for the 7 some odd billion people in this world, and how you make it work out just about right. And what the issue with today's environment, ecology, what we've done to it, and can we actually fix it or not? Technically we can, but there's a cost to everything you do, considering the cost that we had to build up all these systems. Now the cost of breaking down these systems means it changes society, it changes economics, it changes environments, it changes habitats. There's a whole lot of different things that occur because of just a change in how water works. I had a conversation with a friend the other day, and I told them, well, you know what? Technically, if you want to fix the world water problem, where we have less droughts, and technically in the long run we'll have more water. I said, well, technically you can do this, which is take down or get rid of every single major dam on Earth. You're like, what? That doesn't make a whole lot of sense. Once again, welcome to why this channel exists. So let's talk about what these dams do. Yes, they produce power. The reality of it is, let's not care about the power production, hydroelectric part of dams. The whole point of a dam is to store water for whatever consumption need there is. So think of it from this way: is every time we build a dam, we're holding water back so that we can use it for humanity, and to irrigate systems, or so provide water as needed for human civilizations where they normally would not exist because there's not enough water. I'll use example, Hoover Dam. It's the reason why Las Vegas exists the way it does, because it's a desert. There's really not enough water. Millions of people living there realistically is not feasible unless the Hoover Dam exists. Why? It provides electricity and water to that system. If it didn't, then realistically Las Vegas would still be a dust bowl. The tourism, millions and millions of people spending all that time and money and all that stuff there would not exist. So dams, they do that. That's a benefit to having a dam, is it provides this excess just in case you have a need for it for other purposes. So it provides a lot of fresh water, rain, runoff from wherever it is, it pools up in that area, and then we always have excess, so we always let it run, so forth. Grand Coulee Dam, major structures, even the Three Gorges Dam, that's what its design is for. It's to hold back water for excess need. Three Gorges Dam mainly, I think, based upon what I can figure out, is I think they did it for no reason overall except to produce electricity and to show that their government processes are so great. Go figure. Are they? No, because dam hasn't even existed 10 years or so, and there's already problems with the dams. So it goes to show that showing might, or showing being arrogant, it's not necessarily the best thing when you're looking at major public projects, especially if it means you have to relocate 1 billion people. So let's talk about what that does in the long run. Let's talk about the water cycle for a second. How does dams fill with water? It's because of rain. And bottom line is, this goes in a big humongous circle, so we're going to start at some point and get to the rest of it here in a second. So we're going to start with the rain part of it. Rain falls. Doesn't matter where it comes from. It's evaporated because heat causes water to get hot, turns into a cloud, goes over an area and rain falls. So that rain is fresh water. That's how you get pretty much all the fresh water from nature's own resource system. Fills up aquifers, fills up lakes, fills up rivers, and then we dam it up, and what do? We have a humongous amount of water behind the dam, and a lower level of water. We can use it for electricity, but we can save it, and we can save it. That's the benefit of it. So what's the problem with all of this? The problem is, as we're doing this, evaporation, where does almost all the water on Earth come from? It comes from oceans. Like I said, only 3% of the Earth is about 3% is about fresh water. The rest of it, 97% of it is salt water from the ocean. So it's salty water. We can't drink it without dying in the long run. So most of the evaporation that occurs is from the ocean. It evaporates, salt stays, water goes up and comes over to a land area and precipitates. That's how we get the fresh water on land. Yes, does it rain back onto the oceans? Absolutely. But of course, once again, it mixes once again, and you're good. So this seems like such a minute situation, but it actually is a problematic cause from that particular situation. So as we build dams, fresh water or water from the oceans or so, they evaporate, they go on land, and we store it, and it continues that process. Do we release it back into the ocean? Not necessarily. We do it as humanity sees fit, bottom line. So what happens as you evaporate the ocean more and more and more is technically the water gets more salty. Is that a good thing or a bad thing? Technically, if you look at fixing humanity, that's a bad thing. Does the Earth care? No, it doesn't. So let's talk about what happens when these processes occur. So we store the fresh water on land as much as we can, and there are other projects around the world right now that are bigger mega projects to build bigger dams to store more fresh water. So as the water from the ocean evaporates and more of it gets precipitated onto land, the oceans get saltier in a sense. Not by a whole lot. Like I said, it's kind of like if you think about it, 20 years worth of doing this, our salinity, our saltiness of the oceans won't even increase by 1%. But even minute changes to the oceans, what does that mean? It means that the more saline the water is, the more heat has to happen for it to turn into a vapor, for it to evaporate, for it to turn into a cloud. So you have to think of it from that perspective is, hey, the more salt you put in something, the longer it takes to boil. If you want to prove this, it's very, very simple. Throw regular boiling water, it doesn't matter where you're at, boil it. And check that temperature when it starts to boil. Throw 2-3 spoonfuls of salt in it and see what temperature it takes for that to get to boil. The fact is, it takes a lot more heat, more energy for salt water to boil, which means that's when it turns to a vapor in a sense. Well, more heat has to be absorbed, which makes the oceans warmer in a sense. We'll talk about what happens when that process happens. But the warmer the water is before it turns into a vapor, before it turns into a gas, before it goes up and evaporates and turns into a cloud, also means what? That also means that it takes more energy. It has to release more energy, actually, to cool down. So let's talk about the Pacific Ocean and the north or the western side of the United States of America. We live in the U.S. It works the same way everywhere else as well too. But the Pacific Ocean takes a lot more heat to evaporate, more energy to evaporate it. Well, what's going to happen is it's going to still go across the western part of the United States, but for it to cool down enough to precipitate. Will some of it drop off in the Sierra Nevada, so forth as well too? Absolutely, but not as much. It's still going to require more energy. So what does that mean? It's going to move more east, and as it takes longer to cool. If it evaporates and it's moving eastward, well, it's still going to move eastward, but it's going to miss this part or this part of the United States until it cools down enough and it precipitates. So where does it precipitate? Well, if it's still too hot at the coast, then that won't precipitate. So as it gets hotter and hotter, it has to move more eastward. It has to stay up in the air longer, in the atmosphere longer to cool down or to release that energy before it can condensate and precipitate again or otherwise rain again. So you're going to lose all of this water in areas that need it. And then what happens is it rains in the parts like the Midwestern. Why? Because that's where it's going towards before it gets cool enough. So we have plenty of water in the Midwestern, being surrounded on both sides by mountainous peaks means what? The water starts staying there. There are dams in the area, so they're going to be retained there. Is it still going to flow back? Hopefully some of it is still going to flow back to areas that need it, yes. But surprisingly enough, as it misses areas and we preserve our dams, keep more of the fresh water as much as we would like, the cycle completely repeats itself. So it gets more salty. It takes more energy. So more energy means it's going to miss California or Oregon or Washington before it starts raining elsewhere. Maybe towards the more eastern part of Washington or the more eastern part of California versus the middle of California, which is technically where it really needs to rain because that's where it can preserve the water in that particular area. Well, if it can't do that, it can't do that. We build more dams. What does that mean? We're going to have more fresh water and it's going to get more salty. So if you get rid of all the dams, what happens is in about 15, 20 years or so, all the water kind of dilutes itself, gets back to its normal flow, which means what? The systems will go back, hopefully, to a regular system. Now, is that a guarantee? Absolutely not. And the reason why it's not a guarantee is because, once again, we look at carbon dioxide emissions, methane emissions, or whatever it is. Is it causing more heat retention in the atmosphere? Absolutely. So even as evaporates go up into the air, it's getting bombarded by all this energy that's trapped in the atmosphere as the sun shines down on it. So it stays warm and warm and warm. So as more carbon dioxide production occurs, is it still going to miss California? Absolutely. But if we fix the salinity problem, which means it evaporates at a lower temperature, it's going to miss it a whole lot less. So that's the key thing is oceans warming is a conjunction of increased carbon dioxide, which produces more greenhouse gases, which makes the world hotter in a sense. So part of it is the world getting hotter. But as the sun beats down on the ocean, well, one of the ways that it's kind of like your body. How does it cool? It sweats. Well, evaporating water is the way ocean sweats, is how it really gets rid of some of the energy. Well, if it can't do that because it's now saltier and it requires more heat to sweat, the oceans will also get hotter as well too. As the world is overall getting hotter, the increase in salinity, the increase in saltiness makes the oceans hotter overall, makes it an uncomfortable environment. So what does the ocean do to fix this problem? The ocean has currents. So you see these currents on whatever, and they circle in different directions all over the oceans, the Indian Ocean, Atlantic Ocean, whatever it is. There's an Antarctic current as well too, so forth. The thing about these currents is they don't show what the currents actually do. You know, there are parts that show the current going in a circular direction. Okay, it is going in a circular direction, but it doesn't get to show you very well the changes in depth. So at one point that current, maybe it's a hot current from the equator, from the equator, it generates a lot of heat. So the water there, the current rises and it goes in a circle, and as it does, it drops off some of that heat elsewhere. So it drops down that current just a little bit, and then as it gets into the Antarctic side of it, the heat or so is transferred to the ice or so. The ice melts, so the water cools, down or so, drops lower, and so forth, and then gets back to the equator, and it creates that circle. But these are cycles, these are currents that are not just on this top surface. They are currents that go up and down, that change in depth and height or so as these currents flow, because there are changes in temperatures. If it's a hotter current, it's going to rise to the surface. Why? To release that energy, to release that heat. If it's a colder current, then it's going to drop down lower. It's just how the system works overall. Now, the thing about currents is we have major currents and these minor currents. One of the major currents that help to control the temperatures around the ocean is the Humboldt current. If you guys want to know about that, you guys can always YouTube, search, or whatever it is and find all that information out. It is one of the major currents or so that helps to send warm water to the poles, and bottom line is it helps to cool down that water. Of course, the problem with that is everybody's like, oh, it's going to melt the polar ice caps. Absolutely, it's going to melt the polar ice caps. Good and bad. So you melt more of the polar caps. What does that mean? There's more water in the world, more water on Earth that is liquid, that's functional. And what does that mean? Well, oceans will in a sense rise. Absolutely. But that's the way the system tries to cool itself down. But as that fresh water melts, it also decreases the salinity, the saltiness of the oceans as well. So it helps to control how much heat it takes to precipitate. Is it a good thing? Absolutely, because it's going to help control global warming on the ocean side of it, because humanity has this thing for trying to preserve as much fresh water. Well, realistically, if you want to preserve fresh water, you think about a cell phone or a digital camera, a TV. To make a cell phone takes about 3,000 liters or gallons. I mean, there's a whole lot of water that goes into making a cell phone. Well, you buy a cell phone every single year, you're wasting a bunch of water. You know, water preservation, as they say, is one of the key things. People don't realize the importance of water conservation. Water conservation can be something as simple as watering your lawn in the evening times, or really, really early morning, like say 3 o'clock in the morning. And the reason why you do it that instead of noontime is noon is when the sun is out the most. It's the hottest part. So all that water you put out there, a lot of it will evaporate if it's a sunny day. Well, you do it at 3 o'clock in the morning. The sun's not out yet, which means what? It takes about 30-40 minutes to water a lawn, right? A lot of that water will seep underground first. The greenery, or the vegetation on top of it, will help to hold a lot of that water, or that water gets absorbed into the plants or so. And then as the sun comes out, the surface stays a lot cooler because it's able to retain that water in there. And it doesn't get really, really hot. It doesn't evaporate a whole lot. Similar to in the evenings at night times when the sun goes down, was the sun can't heat up the ground because the sun's not there. Same thing. Simple things like that can help. In the long run, what it is that helps the most is appropriate conservation. A lot of people are digging deeper and deeper into aquifers. Is that a good answer? Absolutely not. That's like the worst answer in the world. And the reason why that's the worst answer is because those aquifers, yes, they are fresh, they're clean. You don't really have to do a lot of processing to get that water fresh enough to be drinkable, but that water helps to support the ground all around there. So as you pump out more of water from the aquifers, what happens is that ground will sink and a whole lot more damage will occur because you take water from the aquifers. Realistically, like I said, if you look at how to mitigate the extra heat production, truthfully, and get rid of every dam on Earth, what will happen is the water levels, yes, they'll rise, absolutely. The salinity will decrease enough. Vapor will occur the way it needs to, and temporarily, we might actually get tons and tons of rain. Why? Because as the salinity decreases and the heat, the energy is still there, water vapor is going to occur a whole lot, years. And then after that, hopefully everything levels off. Polar caps or so should start balancing out. I don't think they'll ever get back to normal. It's kind of like Antarctica. The ice shelf is almost 2 miles, or there's a mile and a half, almost 2 miles worth of ice on top of the land there. It's a whole lot of ice. It's a whole lot of water that exists there, which means what? The world, Earth, has a way of mitigating temperature changes for a pretty long time. Yes, the amount of snow and ice that exists in Antarctica gets less and less every single year, but is that okay? Well, it depends. If you're an environmentalist, it's not okay. If you are somebody who looks at humanity's survival, it's a necessity. Has this happened in Earth's lifetime? Absolutely. Is humanity speeding up the process of this happening? Yes. But once again, Earth's been through this before. It knows exactly what to do. It already has a system to fix all of these problems. Am I concerned about it? Well, the good thing is I don't live on the west coast of California. I don't live in areas where precipitation misses me a whole lot. So I have some concerns about humanity there. Truthfully, a whole lot of water didn't exist in Las Vegas, or these areas that humanity decided to settle in, where they did best and optimum for building settlements, for building cities, for building states or so. Not necessarily. So why not go to areas that were designed for human survival? And that's the key thing, is where are we at right now with all of this? You hear a lot of stories about California and the drought that it's causing. They have all this money, supposedly, and the social systems there always keep on complaining every time they try to build a public project. Society has a role to play in it. You always got to give up something for the survival of humanity. If you're not willing to give up something for it, humanity won't survive in that particular area. And that's proof of cause right now is, there's such a humongous drought. Well, what's the problem with the drought in California is the fact that, at some point, people will not be able to sustain living there as easily. The amount of farming that occurs there is going to be decreased quite a bit unless there's enough water to support the agriculture that's there. Is it going to have an effect overall on the world? Yes. So what do we do about that? More than likely, to preserve more water, we're going to be pumping in water from other systems. We're going to start building other duct systems and other pump stations or so forth to be able to send water wherever it's needed. That's humans' way of doing it. Nature's way of doing it is it will find a way, one way or the other, to decrease the salinity of the oceans, and it already started that process. Icebergs are melting, whatever it is. Is it necessary? Absolutely. So people freak out about that. Yeah, it's going to cause rises in sea levels. Don't live next to the coast. There's plenty of space around the world where it's a lot safer to live. So why not live there? And that's the key thing is people says, well, this and that I want. And that's the key thing is, do they want to live next to the beach? Absolutely. It's a want. Buying a cell phone every single 6 months is a want. Having air conditioning technically is a want. Having a cell phone is a want. Having a refrigerator is a want. Well, all these things take up all the fresh water because it takes a lot of fresh water to manufacture anything that has electronics or it has to deal with electronics. You want to help the world or so, well, don't be pushy about the electronics. Make them last a little bit longer, regardless if it's a car or your cell phone. Preserve water by not overutilizing it. Everybody wants a lawn. Lawns cost a lot of water, and it's not about the money, but it is about what environment you're in Well, if you're in a desert and you want a green lawn, you're still the problem. Even though you might be taking 5-minute showers, if you're still having your lawn green, that mentality is the reason why we have such a lack of fresh water. Even though we have more than enough fresh water with the current amount of fresh water that exists on Earth, that exists in this world. Thank you.